This is chapter 17. We're going to flip to page 446, where you're going to write your first sticky note for the chapter. You have to know what percentage of nitrogen and oxygen are in the atmosphere. We mostly breathe in oxygen because oxygen is more dense than nitrogen. So since it's more dense, it falls to closer to where we are. And nitrogen is less dense, so it rises. And it falls because of gravity. Gravity causes the more dense particles to come closer to the surface of the earth. And so nitrogen is what most of the atmosphere is made up of, but oxygen is more concentrated towards us. On this page, on 447, know the different layers of the atmosphere: troposphere, stratosphere, mesosphere, and thermosphere. And also exosphere, which you have to add, it's not in your book. So the troposphere is where we are, it's where weather happens, it is where global warming happens. It has the highest density, highest pressure, most air particles, because gravity is bringing most of the air particles down to the surface of the earth. So they're mostly concentrated right here where we are, and it's less dense, and you're going to have less atmospheric pressure here at the exosphere. So a lot of things happen in the troposphere. Most things happen except in the stratosphere. That is where the ozone layer is, which protects us from the sun's harmful UV rays, which can cause skin cancer. And so that's good right here. Ozone is bad when it's in the troposphere. It's bad to breathe in for us, and it can form from air pollution from cars. When we burn fossil fuels, it can be harmful to us. But ozone is harmful in general, even here, but we're not in the stratosphere, so it doesn't affect us here. It's good for us here because it blocks the sun's rays. No atmospheric pressure, and this diagram about atmospheric pressure. And again, the density of air molecules is most here towards the surface of the earth. No relative humidity, convective circulation, and weather versus climate and the difference. And this is on the next page, weather and climate. Microclimate is something that's not in your book, so it's starred. It is a small area where the climate in that area differs from the surrounding area. So this can be a small area like a garden, or bricks on a house can be warmer than the surrounding atmosphere, or it can be a town or a small city like San Francisco is colder than the surrounding area. That's a microclimate. And then also know this figure and caption here. This is about why the equator is hotter than the other parts of the earth. It's because of how sunlight hits the equator. It hits it at a 90-degree angle, so sunlight travels through less atmosphere to get here. So the rays are more direct. Over here in the northern hemisphere, like where we are, the angle is different, and so the sunlight's traveling through more atmosphere. It's going to not be as direct. It goes through a longer path and absorbs more energy, so less energy is heat. 449, page 449, know the seasons. What causes the seasons, which is the tilt of the earth. It's 23.5 degrees, and a tilt on the axis, and then also the rotation of the earth. We rotate around the sun once a year, and in our summer is in June and July. It's hotter because at that time the northern hemisphere is facing the sun, so we're hotter here. The southern hemisphere has their winter then, and then in our winter time we're facing away from the sun, and in the months of December, places like Australia have their in December they have their summer because they're facing the sun at that time. So it's the opposite. They have opposite seasons in the southern hemisphere and in the northern hemisphere. So know that diagram and caption, and then know this convective cell is important. This happens not only in the atmosphere, but also in bodies of water and in the magma in the mantle, and that's what drives plate tectonics. So how it works is in the atmosphere, the sun's light hits the surface of the earth, and the heat slowly dissipates off of the surface. So it's going to be warmer near the surface of the earth because of that. But hot air rises while cool air falls and sinks. So the hot air here, it's going to rise, it's going to get cooler, form clouds, and then it's going to cause precipitation. And the dry air is going to move this way. It's going to then sink because it's cold, and then it's going to warm up again. So it's this cycle. And on the Earth, this right here, this part is at the equator. So there's tropical rainforest here. It rains a lot. This is at the equator. The air that moves up, moves away from the equator in both directions. And so kind of around where we are more north, the air falls and then it's drier. So here are some weather terms. High pressure system means fair weather, sunny, nice weather. Low pressure system means precipitation and rain like this. 450, page 450, temperature inversion is right here. So you have to know what temperature inversion is. This is normal conditions where it's warmer near the surface of the earth because the sun warms the surface, and it's cooler up here. And so any pollution from a city is going to move up, which is good. It's getting away from the city. But in a temperature inversion, these temperature gradients flip, and so it's cooler down here and it's warmer in the upper atmosphere. And so that can trap pollution. And usually it happens, and the type of pollution that it traps is usually something called smog and air particulates. So that's what makes it look this cloudy dark color, that's smog. And it tends to happen near coasts where an ocean breeze blows cool air under warm air. And it can also happen in cities next to mountains. So that's right here. And this city is in a valley, and so this mountain's going to cast a shadow down here. It's going to cool this area, but the upper atmosphere is still being warmed. So this happens especially in the summertime when the days are longer and there's more sunlight, causing more pollution, and also it's warming the atmosphere for a longer time while this cooling effect is going on. So it happens a lot in temperature inversions happen in LA, Mexico City, in a lot of valleys like Denver. And so make sure you get this and this right here, which is what I just explained. Page 451, make sure you know what the Coriolis effect is. And that Coriolis effect makes winds. It's how winds occur. And it's a combination of convection cells and the spin of the earth. It causes the air to be deflected in a curved manner. So right here is a convective cell, or two convective cells right here. These are called Hadley cells, and they happen around the equator. So at the equator, that warm air rises, clouds form, and then it causes precipitation. That's why at the equator there's more tropical regions, there's more rain, it's hotter there. And that air is going to move here. It's going to be dry, it's cold, so it's going to sink, and that's going to cause arid regions. Arid means dry. So in this picture right here, know this, and there are these different cells. There's Hadley, Ferrel, and polar cells, but just know Hadley cells. Hadley cells are at the equator and then 30 north and 30 south. Over here, 30 north and 30 south tend to be deserts and dry or arid regions. And then also, this system right here, feral and polar cells, air rises here, so it causes precipitation in a moist climate at 60 north and 60 south as well. And then when the air falls and the dry air falls, that's in the polar regions, and that's where tundras are. Remember, tundras are dry, and that's why. So make sure you write down this. Deserts and arid climates occur at 30 north, south, and near the poles. And the equator and 60 north and south are usually going to be rainy. At 60 north, that's where boreal forests occur. On page 450 and 452, know what hurricanes are and know what tornadoes are. And that's it for right now.